Welcome students. This today's lecture we are going to learn about the program evaluation and review technique. That is short form of this is called as a PERT. It is the second method of project review technique. The earlier we have gone through CPM, that is critical path method. The second one method, that is PERT. Okay, so what is PERT that we are going to see first? PERT means it is a probabilistic model with uncertainty in the activity duration. So the activity duration in the PERT model, which is not known certainly. So there is uncertainty in the duration that we cannot guess the exact time required to complete the activity. That's why this model is called as a probabilistic model. So that's why we estimate the 3 times in case of PERT, and the time that we considered in the PERT, that is optimistic time, that is short form, that is the TO, then most likely time, that is TM, and pessimistic time, that is called as a TP. So we consider all these 3 times, that is optimistic time, most likely time, and pessimistic time, to calculate the actual time, or we can say the probable time, and that time is called as the expected time. So by considering these 3 times, TO, TM, and TP, we calculate the expected time to complete that particular activity. So the formula for TE is the TO plus 4TM plus TP divided by 6. This formula we are using to calculate the expected time to complete an activity. So why we consider these 3 times? So suppose optimistic time that we considered, by considering that everything is going on smoothly while completing that activity. If while completing the activity, during that activity, if everything is going on smoothly, then how much time it will take, that probable time that activity completion time that it take, that is called as the optimistic time. Most likely time is that we consider with a normal pace. So in the optimistic time we consider the faster pace. In the most likely time we consider the normal pace. If the activities are going on with the normal pace, then how much time it take, that is we consider as the most likely time. And the pessimistic time, if everything goes wrong, if everything is going wrong, some we are not unable to use or generate the resources, or anything mishappen during the completion of the activity, then how much time it take, that we consider that the pessimistic time. That's why in the formula we are given the four weightage for the most likely time. Here we have given the weightage, more weightage for the most likely time, that is 4, and in the optimistic time, pessimistic time, we have given only the 1 as a weightage divided by 6. So this formula we are using to calculate the that is the expected time. Then we have to add this probabilistic model. That's why the one more point comes arise in front of us, that is the standard deviation. So everybody is aware about the standard deviation. The standard deviation means it is the deviation from the mean value. It is the deviation of the value from the mean, because it's a probabilistic model. That's why we cannot reach at the exact that value. That's why we are using the standard deviation. So for this we are using the formula for the sigma, that is the TP minus TO divided by 6. TP minus TO divided by 6. This formula we are using for the calculation of the standard deviation. Now, as I told you, the explain the TO, TM, and TP. In this case, if you observe this after in the problem, the pessimistic time is large one. Value of the pessimistic time is large one than the most likely, and optimistic is the minimum time, in the less time in the all these 3 type of timing. So we consider when we go through the one problem. So see, this is a simple problem. A small project is composed of the following activities whose time estimates are given below. So activity duration is given in a unit of weeks. So activities are 1 to 2, optimistic time 1, most likely 1, pessimistic 7. So like this time is given for all the activities. In the first column it indicates the activities 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, and 5 to 6, like this. These are the activities and the respective time required for that to completion the activities. There is a TO, TM, and TP. These are the 3 times. And as I told you, if you go through all this table, you will find that the more pessimistic time is more than the earlier two, as I told you, and in the TO is a less value than these two. Okay, so we need to use this matrix for the solving the problem. So what we have to find, see, first one question is that draw the network diagram, then find the critical path, find the expected duration and the variance for each activity, calculate the standard deviation of the project length, and we need to find out the probability that the project will completed at least 4 weeks earlier than the expected time. So we calculate the expected time, and that we need to calculate the probability that the project get completed before than earlier than the expected time, 4 weeks earlier, and no more than 4 weeks later, so after expected time. And the next one is the 19 weeks, that probability we need to find, and we need to find the duration for the 95% probability. So this we have to find. Now by using this value, all the values in this, that is activity 1, TO, TP and TM, by using this value we need to calculate the expected time. So as I told you, the formula for to calculate the expected time is T is equal to TO plus TM plus TP divided by 6, and for the standard deviation it is TP minus TO divided by 6, and then we need to calculate the variance, and variance is nothing but the square of standard deviation. So in the 1 to 2 I will calculate one sample. See, is optimistic time 1, most likely is 1, pessimistic 7. So TO means 1 plus 4 TM means 4 into 1, that is 4, plus TP 7. So 4 plus 1 5, 5 plus 7, that is 12, 12 divided by 6, that is equal to 2. So put all this value, TO, this optimistic means TO, TM means most likely, and TP means pessimistic. Put all these values in this formula and you will get these values. Similarly, you can find out the standard deviation by using this formula. So TP here there is 7 minus TO, that is 1, 7 minus 1, 6, 6 divided by 6, that is equal to 1, and the variance is equal to the square of this sigma value. So 1 square is equal to 1. So like this we calculate all this timing, that is expected time, we calculate the expected time T, then we calculate standard deviation, that is sigma, and then we calculate the variance, that is sigma square. So like this we calculate all these values. Then we need to draw the network diagram. So I already told you, I will discuss in our last lecture, that is CPM, how to draw this network diagram. So in this activities are given. So in this table I have mentioned this T rather than C. In this table I have mentioned the TO, TM and TP. Now this TO, TM and TP I have converted into the T values, and that these T values we are going to use henceforth. So in this 1 to 2 activity it takes the 2, 1 to 3 it takes 4, 1 to 4 it takes 3, 2 to 5 1, 3 to 5 6, 4 to 6 5, and 5 to 6 7. So these are the duration required to complete this activities in weeks expected time. So we are going to draw the network diagram for this. So to draw the network diagram, see, 1 stands for, in the last lecture, that is during CPM, I already discussed about how to draw the network diagram. So please go through that, you will get how to draw this network diagrams. Now see, once again I will tell you, this 1 phase means it is the presiding activity, and second, these are the nodes. 1 is the first node, second is the 2 is the second node, and 1 to 2 is the activity. So 1 to 2 means it is activity starting from node 1. 1 to 3 means this activity is also starting from node 1, and 1 to 4 this activity is also starting from node 1. So these 3 activities are starting from the single node, that is 1. So how to draw this? See, first of all we locate the first node, that is 1. Then we draw 1 to 2 activity. This is a 2, 1 to 2. This is the first node, the second node, and this arrow stands for this activity. Then 1 to 3. So I draw one arrow. Then this is the third activity. 1 2 3. This is the activity. Then 1 to 4. That is also starting from 1. So this is the next one. fourth one, and this is the arrow for that 4, and this is the activity 1 4. Then to 2 5, next activity is a 2 5. So its starting node for this activity is 2 5, is the starting node is the second 2, and that is starting from here. And next activity, that is 3 to 5, that is starting from third node and it ends at 5. So there are two activities are there, 2 5 and 3 5, that ends at the node 5. So we need to draw this fifth activity here, because there is a 2 5 activity and 3 5 activity, so this network should be balanced. That's why we draw like this. So I draw this 2 to 5 like this. So this is the fifth one, and this is the 3 5. So this is the 2 5 activity, and this is the 3 5 activity. The next one is the 4 6 and 5 6. So the end of this 4 6 activity is 6 node, and 5 6 is the 6th node. So I draw here one circle. So 4 6 will be this one, and 5 6 from this side. So here this is the 4 6 activity 6, and this is the 5 6 activity. So like this, complete all the network diagram by using this all these activities 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 5 to 6, and 4 to 6. Now we are going to write all this expected time on these respective activities. So like this, see 1 to 2 activity get 2 weeks. So I write here 1 to 2 activity here 2. Then 1 to 3 that takes 4 weeks. So I write here 4. 1 to 4 takes 3 weeks. So I write here 3. Like this, on every activity we write the expected time, respective expected time on that each activity. After that, after this, we need to find out the critical path. So this already we have completed in the last slide. Now how to find the critical path? Critical path means that path which takes the longer time. So why it is called as a critical path? Because see, on that path all the activities are critical one. Critical one means if any activity get delayed on that path, the entire project get delayed. That's why that activity or that path is known as a critical path, because if any activity get delayed on that path, that entire project get delayed. So we need to find here alternative path here. So it is alternative path is 1 to 2, 2 to 5, and 5 to 6. See, this is the alternative path first, 1 to 2, 2 to 5, 5 to 6. Next alternative path is 1 to 3, 3 to 5, 5 to 6, and next alternative path is 1 to 4 and 4 to 6. So like this, there are three possible paths are there. So we make the chart of that possible paths: 1 to 2, 2 to 5, 5 to 6, 1 to 3, 3 to 5, 5 to 6, and 1 4 6. And make the addition of all these activity paths. See, 1 to 2, 2 to 5, and 3 to 5 to 6 means 2 plus 1 plus 7, and is equal to 10. And 1 3 5 6 is 1 3 4 plus 6 10 plus 7, that is 17, and 1 4 6, this is a path. So 3 plus 5, that is equal to 8. So this is the duration of every path, and the path which takes the maximum time, that is 17 here. So this path is known as a critical path. 1 3 5 6, this is the critical path. If any activity get delayed, see here the maximum project duration is 17 weeks, right? So if suppose any activity on this path, that is 1 3 3 5 5 6, any activity get delayed by 1 day, say suppose 1 3 activity get delayed by 1 day, that is if it takes 5 weeks, then entire project duration will completed after 18 weeks. That's why these are known as a critical path. Now after this, we need to calculate the variance of this. So this is the variance of the project length. As a variance means, see, whatever the highlighted activities, these are the activities on the critical path. See, on the critical path the activities are 1 3 3 5 5 6. So hereafter, while calculating the probability, we need to concentrate on these activities only. So 1 3 3 5 5 6, on these activities we are going to concentrate, and we are considering the variance of these three activities only, 1 4 4, right? So the variance is equal to 1 plus 4 plus 4, that is 9. And see, here we make the square of this standard deviation to convert it into the variance. Now to calculate the standard deviation, again we need to take the square root of this sigma square of entire project length. So that is equal to standard deviation of the project length is equal to square root of 9. So the variance of the project length is equal to 1 plus 4 plus 4. Here there is a 1. 1 to 3 activity variance is 1. 3 5 activity variance is 4, and 5 6 variance is equal to 4. So that is equal to 9. and the square root of that 9 is equal to 3 weeks. So the standard deviation for this project length is 3 weeks. Now here, this is the standard normal distribution curve. This curve we are going to consider to calculate the probability of in this PERT model. Okay, so you know about this bell curve, right? Now the first question that is asked, there is a probability that project will completed at least 4 weeks earlier than the expected time. 4 weeks earlier expected time. Expected time in this problem that we have calculated is 17 weeks, right? So 17 weeks earlier than the that expected time. So 17 minus 4, that is equal to 13 weeks. So we need to calculate the probability that the project will get completed within 13 weeks. Within 13 weeks, because it is asked to calculate the probability that the project will complete at least 4 weeks earlier. 4 weeks earlier, 17 minus 4, that is 13 weeks. So how to calculate it? So for the bell curve, we need to find out the z value. And how to calculate the z value? That is a due date. Due date means the project completion date, due date minus expected time. That is expected time. In this problem, it is 17 divided by standard deviation that we calculated in the last slide. So due date is 13, so 13 minus expected time 17 minus standard deviation 3. So if when you calculate this z, you will get the z as a 1 minus 1.33. Now what does it mean? See, if I draw this bell curve, if you draw this bell curve, at the center it is 17. At the center it is 17 because it is expected time, so we mark at the 17 at the middle. There is a 0.5 area on the right side and 0.5 on the left side. So 13 is less than 17. 13 is less than 17. So obviously it will come to the left side of this 17. It will come on the left side of the 17. So I draw here one line that is that denotes the 13. Now we need to find out the area for the 13. So we need to find out the probability that project will get completed within 13 weeks. So that's why we consider the area left side of the 13 line. So this area, we need to consider this area on the left side of 13. So now how to find out this area? So for this purpose, we need to refer the normal distribution curve by using this z values as 1.33. So this is a standard normal distribution curve. Normal distribution table. So our value is 1.33. So see, on this side, z side, we take the 1.3. Here there is a 1.3. So don't note this. This is the 1.3, and on the column side we consider the 0.03. So 1.3, and from the column side there is a 0.03. So the value is 0.4082. That is highlighted value is 0.4082. So we consider this value as a 0.4082 in this, that is the area under curve is 0.4082. So thus the probability that project will complete at least 4 weeks earlier expected time, that is 0.4082, and it is also known as a 40.82%. This probability is also known as a 40.82%. Now after calculation of the first one, in the B part, we are going to find out probability that the project will be completed no more than 4 weeks later than the expected time. So in the earlier point, we are going to calculate before 4 weeks, that is 17 minus 4. Now here later 4 weeks, that's why here we are going to add that. So the probability that the project will get completed no more than 4 weeks later than the expected time means the expected time of the project completion is the that is 17 plus 4, that is 21. So due date here we consider as a 21. Due date we consider as a 21 minus expected time 17 divided by 3. So how it comes to 21? That is 17 plus 4. That's why it is 21, because we calculate the project will be completed no more than 4 weeks. That's why we consider the 21. So by calculating this, you will get the find the value as 1.33. So already we have find out the area under this curve 1.33. Once again I will show you that area. See, 1.33 means here we consider 1.3 on the z side 1.3, and from the h side, that is height out of this 1.3, and this is 0.3, that is 1.3. 33. In the combination it becomes the 1.33. So it is 40.82. Sorry, 0.4082. Now do remember, in the earlier one it is less than 17. So we take the area on the left side. So, but here see, in the earlier one we consider the 39 on the left side here, because it is less than the 17, so we take the area less than 13. That's why we consider the area on the left side of 13. But here we need to find out the area under for the 21. So it definitely it is on the right side of the 17. So the 21 line will be here on the right side of this, and we need to find the area of this entire area from this side. Okay, so this area is a 0.5. We know that this area is 0.5 plus the area under curve is a 0.4082. So it becomes 0.5 plus 0.482. So that is the it comes, that is a 0.9082. That is also equal to 90.82%. So this is the probability that the project will completed within 21 weeks. So like this we find out, this is 0.5 that we consider the area on this side, and then this 0.482. So this area. Okay. Now the next one is this one. See, if the project due date is 19 weeks, project due date is 19 weeks. So the earlier was it is we consider the 21, and it is here we consider the 19 weeks. Now probability of not meeting the schedule, probability that we need to find out that not meeting, so means the project not get completed, that we need to find. In the earlier two problems we find out that project get completed, here not get completed. That is important, the changes in the earlier two and this one problem. The earlier one we calculate the project will get completed, here the project not meeting the schedule. So how to find out this? So this is a z, we need to calculate z again. This due date 19 minus 17, that is divided by 3, that it comes the 0.66. So by using normal distribution that chart, so 0.66, see this is the 0.6, okay, 0.6, and from this side 0.06, the area under curve is 0.2454. the area under curve is 0.2454. So firstly we need to calculate, see, 0.2454. So not meeting is this area, see, 0.2454. so not meeting, we need to calculate the not meeting. That's why we have to find out the area of on this side. See, area on the right side of, see, 19, that project will get completed within 90 days. To find out that, we consider the area on left side of 19. See, left side of 19. So we consider the 0.5 this area, and 0.25, the 0.2454 this, 0.2454 this area, 17 to 19 this area. But in this case we are going to find out the probability of not meeting the schedule. That's why we consider the area on the right side of 19. We need to find out this. Now this 2454, the area under there's a 2454, this is the area between this 17 and 19, okay, and we want this area, we want on the right side of the 19 area, and the area on the right side of the 17 is entire area is 0.5, and 17 to 19 it is the 2454. So to find the probability of not meeting the schedule, how we calculate this? 0.5 minus 0.2454. So 0.5 is the area on the right side of the 17, and 0.2454 is the area between 17 to 19, and we want the area on the right side of 19. That's why 0.5 minus 0.2454, that becomes 0.2546. that is also equal to 25.46%. In terms of percent, the probability is 25.46 of the probability that the project not meeting in the 19 weeks. So like this we calculate this, okay, or we can calculate like this also. See, this entire area of the standard distribution curve is 0.5 on the right side of the 17, and on the left side there is 0.5, and on the right side there is 0.5. So the entire area is 1, and we want the area below this. So if we add these two, 0.5 plus 0.2454 minus 1, so if you deduct 1 minus 0.5 and 0.24, you will get the same answer. It is the meaning the same. So like this also we can calculate this. Okay, now the next part, see the probability of 95% that project duration will be. So here the question is reverse one. In the earlier case, we try to find out the duration, we try to find out the probability of the project completion of the given duration time. But here the probability is given and we need to find out the activity duration. We need to find out the project duration. That is the reverse one. So see, the area under there is a 95% probability means it is value is 0.95, and we know that the maximum area, that is 0.5. So we distribute this 95, or we break this 95 into zero point 0.5 plus 0.45. The maximum area is 0.5, that's why we break this 0.95 into 2, that is 2 segments, that is 0.5 plus 0.45. Now by using this 0.5, we know that the area on the left side or right side, and to find out the 0.45, we again refer the standard normal distribution chart. So in this normal distribution chart, 0.45, see, we are going to find out the closest value of this. See here there is 0.4495 and it is here it is 0.4505. So we consider this value. Okay, 0.4505, this is the closest value. So the Z value for this 0.45 is the 1.6, and on this chart it is a 0.05. So the Z value is 1.65. This is the value for this respective value. Okay. So here we consider the for normal distribution table, the value of Z for the area 0.45 is 1.65. Okay, so here it is a 0.45, that's why we consider the area under curve as 0.4505, because the earlier one is the 0.4495, so that's why we go for the 0.4505, and that the Z value for that respective is 1.65. So by using this 1.65 value, by using the earlier formula, that is Z is equal to due date minus expected time of our standard deviation, we find the this area. So corresponding Z value is the 1.65 for this area 0.45. So by using this formula, we need to find out the due date. So put all these values, that the Z is equal to 1.65, and we know we want to find out the due date. Expected time is 0.17 and the standard is 3. So due date is 1.65 is equal to due date minus 17 divided by 3, and when you calculate this, you will get the due date is equal to 21.95 weeks. So it means that the 21 get completed, 22 weeks is pending. So that's why we consider this as a 22 weeks. Though it is a 21.95 weeks, we consider this as a 22 weeks is as our answer. So this is all about our this subject or this topic, that is a PERT. I think you will get all this, got that, understand this topic and understand this all the problem. If you have any query, please comment in the comment box, and I try to solve that problem also. Thanks for watching. Please like to this video, comment and subscribe to my channel. Ask your friends to subscribe my channels, share to your friends, so that they will also get benefited because of these videos. Thank you for watching.